So any point in the Cartesian coordinate system is uniquely represented in the space using three coordinates that are x, y and z. For example, if the given point is P, 1, 2, 3, x is 1, that means its perpendicular distance from the yz plane is 1 unit. Y is 2, that means its perpendicular distance from the xz plane is 2 unit. Similarly, z is 3, that means this point is at a distance of 3 unit from the xy plane. So combining all these x, y and z coordinates, this point P is uniquely represented in the space. But my dear, let us assume that we are given with only x equal to 1. Nothing is said about y and z. Y and z can be anything. We are asked to find the locus of x equal to 1, x equal to constant. Y and z can be anything, can be don't care. So my dear, once again, recall the definition of x coordinate. It is the perpendicular distance from the yz plane. If it is positive, the distance should be taken in the positive direction. If it is negative, the distance should be taken in the backward negative direction, whatever. It is the perpendicular distance from the yz plane. That means we want to find the locus of all such points which are at a distance of 1 unit from the yz plane. And as you can see from the figure, if we want to draw the locus of all the points of x equal to 1, that means all the points which are at a distance of 1 unit from the yz plane, then we get a plane, we get a surface which is parallel to the yz plane at x equal to 1, as you can clearly see from the diagram. Had I taken x equal to 4 locus, again I would have got the plane or the surface which is parallel to yz plane at x equal to 4. Had I taken the x equal to -2, again I would have got a plane or a surface which is parallel to yz plane but at x equal to -2. So my dear, what I am trying to convince you, whatever x equal to 1, 2, 3, -4, -8, whatever, x equal to constant, the locus of x equal to constant leads to the plane, leads to the surface which is parallel to yz plane at that x. On the similar lines, the locus of y equal to constant will be a plane or a surface parallel to xz plane at that y. And finally, z equal to constant. Constant means anything. Z equal to 1, 3, -4, whatever. Z equal to constant. X and y, they are variables. They can be anything. The locus of z equal to constant will also be a plane or surface which is parallel to xy plane at that z. You know, it is very easy to remember. Locus of x coordinate equal to constant. Skip the x-axis. A plane parallel to yz plane. Y equal to constant. Skip the y-axis. Plane parallel to xz plane. Z equal to constant. Skip the z-axis. Plane parallel to xy plane. Isn't this very simple? So locus of any one point equal to constant and rest to maybe variables. X equal to constant, yz variables, or y equal to constant, xz variables, or z equal to constant, xy variables. Locus of one coordinate equal to constant represents a plane or surface that is parallel to one of the reference planes. And my dear, you know, you should remember its converse also. That means if it is a plane or if it is a surface, then its equation will be one coordinate equal to constant, rest two will be variables. Again I am repeating, the equation of the plane or the surface is nothing but the one coordinate constant and rest two, they are variables. But be careful, my dear, this is not 100% true, because you know the equation of the planes, the equations of the planes and surfaces, they can be very complex, as we will see as we move on in the syllabus. But in EMT, we generally deal with the planes or surfaces that are parallel to reference planes. And hence, as if now, we can remember like this. The equation of plane or the surface is nothing but one coordinate equal to constant and rest two are variables. If the given plane is parallel to xy plane, then as we have just discussed, its equation will be z equal to constant, x and y are variables. If the given plane is parallel to yz plane, then its equation will be x equal to constant, y and z are variables, and likewise for the other. So the equation of plane or surface is one coordinate equal to constant. One more point, all the points that are present on the plane or the surface have one coordinate same, have one coordinate constant. For example, consider this plane x equal to 3 and consider any 2 points that are present on the plane P and Q. So my dear, the x coordinate of both of these points P and Q will be exactly same, equal to 3. Because both the points are present on the same plane. Both the points are at a perpendicular distance of 3 from the yz plane. Am I right? So all the points from the given plane have one coordinate same. Their y and z coordinates may be different. As they are different points, their y and z may be different. But all the points from the given plane have one coordinate same. But again I am repeating, these results are applicable only for the standard planes or standard surfaces which are parallel to one of the reference surfaces. Now let us find the locus for two coordinates equal to constant. Only one is variable. Let us say we are given with x equal to 2 and y equal to 3. Z is variable. So let us find the locus for x equal to 2, y equal to 3 and z is variable. We have just discussed that x equal to constant will represent a plane parallel to yz plane. Y equal to constant will represent a plane parallel to xz plane. So x equal to 2 will represent a plane parallel to yz as shown in the figure, and y equal to 3 will also represent a plane parallel to xz plane at y equal to 3 as shown in the figure. Now my dear, we want the combined locus of x equal to 2 and y equal to 3. That means our required locus is the intersection of these two planes. Am I right? And as you can see clearly from the figure that the intersection of these two planes is a line which is parallel to z-axis and perpendicular to xy plane. Am I right? So the required locus of x equal to 2 and y equal to 3 is a line parallel to z-axis and perpendicular to xy plane. So my dear, let us now generalize it. So if out of 3 coordinates, 2 coordinates are given constant, only one is variable, then that represents a line parallel to one of the coordinate axes. X equal to constant and y equal to constant. Z is variable. It will be a line parallel to z axis as we have just seen and perpendicular to xy plane. My dear, it is very easy to remember. The line is always parallel to the axis for which the coordinate is variable or for which the coordinate which is not constant. What we have considered, x equal to 2 and y equal to 3, x and y were constants, only z was variable, so our line was parallel to z axis. Similarly, if y equal to constant and z equal to constant, only x is variable, then that line will be parallel to x axis. If z is constant and x is constant, only y is variable, then that line will be parallel to y axis and perpendicular to xz plane. So any out of 3, any 2 coordinates constant, only one is variable, then this represents a line parallel to one of the axes for which coordinate is variable. Now as I explained in the planes, let us make the converse. If we are given with the line which is parallel to one of the reference axes, then its equation will be any two coordinates constant, only one will be variable. Out of three, any two can be constant, only one will be a variable. For example, if line is parallel to a x-axis, then its equation will be y equal to constant and z equal to constant. Only x will be variable. My dear, y and z can be constant at any values. Y equal to 3, z equal to 4. Y equal to minus 3, z equal to 0. Y equal to minus 8, z equal to minus whatever. But if that line is parallel to x-axis, that means its equation will be y equal to constant and z equal to constant. Only x will be a variable. Similarly, if the given line is parallel to y-axis, now you know its equation will be x equal to constant and z equal to constant. It's y only variable. And finally, if line is parallel to z-axis, its equation will be x equal to constant and y equal to constant. Only the z will be variable. One more point. All the points that are present on such line, they have same two coordinates. They are differ only by one single coordinate. For example, if I am given with the line x equal to 3 and y equal to 4, x equal to 3, y equal to 4, x equal to constant, y equal to constant. So my dear, this will be the line, as we have just seen, this will be the line parallel to z-axis like this. So consider any two points on this line, let us say p and q. So what I am trying to say you, the x coordinate for p and q will be same at 3 and y coordinate of p and q will be same at 4. Because you know, both the points are present on the same line defined by x equal to 3 and y equal to 4. Yes, their z may be different. As these points are different, let us say p has z1 and q has z5, their z may be different. But all the points that are present on such line will have same x and y coordinates. Their z may be different. So you know, all the points which are present on such lines, they have two coordinates exactly the same. They are differed only by one single coordinate. My dear, again I am warning you, all this discussion is applicable only to the standard lines that we generally face in EMT. Standard lines means the lines which are parallel to one of the XYZ reference axes, isn't it? Now finally, let us say we are given with all coordinates equal to constant, x equal to 1, y equal to 2, z equal to 3. My dear, if one coordinate was constant, rest two were variables, then we got a plane. If two coordinates are constant, only one was variable, any two constant, one was variable, then we got the intersection of these two planes, that was a line. So one coordinate constant, two variables, that was a plane. Two coordinates constant, one variable, that was a line. Now here we have all three constants. So our required locus will be the intersection of all these three planes, x equal to 1, y equal to 2 and z equal to 3. And as you can see from the figure, the intersection of all these three planes is nothing but the unique point in the space, that is like this. It is also called as coordinates of that point. Am I right? So all three constants, that means it is a unique point in the space. My dear, you can clearly observe from the diagram that this diagram looks like a rectangular block, a rectangular paralleloid. Am I right? It appears that the point is sitting on the vertex of rectangular block. And that is the reason why this Cartesian coordinate system is also called as a rectangular coordinate system.